Good day, everyone. Welcome to my YouTube channel, Metrics Ed. My channel is an educational channel where I would be treating with you subjects like math and science. In this channel, I will be discussing with you some very vital and challenging topics in mathematics and science. At the end of this video, don't forget to like, share, and subscribe. Now, I'm going to bring you up to speed on the foundational knowledge required in mathematics. So that means I'll be starting with math as a subject, and I'll be treating with you the basic knowledge that we need in math, which is numbers, and from there on, we can build on it till we get to a very reasonable and challenging point. Now, numbers. Now, when you talk of numbers, we define numbers as arithmetic values. Now, look at the words. Arithmetic values. Those are very vital and key points. So we say we define numbers as arithmetic values used in representing a quantity. Look at that. Arithmetic. We know in math, we usually make use of the word arithmetic. And arithmetic as a word in math means that maybe peradventure, after adding or subtracting, multiplying or dividing, obtaining the square, obtaining the square root, obtaining the cube root, and so on and so forth. As we all know that those things I mentioned, starting from addition to subtraction and so on and so forth I mentioned, are referred to as mathematical symbols or signs. So we say that when is that we apply any of those mathematical or arithmetic symbols on values, and we use it to represent a quantity. So what do we mean by a quantity? A quantity is something that can be measured, something that can be ascertained by virtue of what we use something to measure. So we refer to such as what? As a number. I'll go again. So we define numbers as arithmetic values used in representing a quantity. So that means when is that you have a value of something and we use it to represent a quantity, such a thing or an expression is referred to as numbers. Now, for instance, if they say the height of a boy is 180 centimeter. Look at that. The height of a boy is 180 centimeter. That means we are using the arithmetical value after quantifying the height of a boy. We are using the arithmetical value 180 to represent the height of a boy in terms of centimeter. So this expression that comes after the number, after the quantified arithmetical value, is referred to as the unit. So 180 is what we use to represent the height of a boy. So 180 as it stands is referred to as a number. Another instance, the distance covered by a girl is 25.5 kilometer. Look at that. The distance covered by a girl is 25.5 kilometer. So that means the distance, horizontal distance covered by the girl in terms of the arithmetical value after quantifying, that is after measuring, is 25.5. In terms of what? Kilometer. And kilometer is also a unit of what? Of distance. Anything that has to do with measuring in terms of length. It can be horizontal, which is for the case of distance. It can be vertical, for the case of the height of the boy, which is centimeter. So, another instance. So don't let me just be using things that has to do with length. Another instance, if they say the value of the constant 22/7 is equal to 3.142 dash dash dash. and so on and so forth. That dash, dash, dash means, and it's continuous till we are fed up writing anything after the decimal point, because such numbers, I'll be treating with you what type of number it falls under. So it implies that this constant 22/7, which is what is still represented using the symbol pi in terms, not in terms of radian, pi as a constant, because pi as a constant is different from pi as a radian. So when is that you express the constant pi, which is 22/7, to be 3.142, though it has no unit. So we say such an expression is a number, either 22/7 or 3.142 is what? Is a number. Another instance, let me give you the pi of radian. If they say pi radian is equal to 180 degree, look at now, we know we use the symbol degree to represent angles, and some other thing that has to do with angles. So when is that you talk of the pi as a radian is 180 degree. So that means this value 180 degree expresses the amount of that constant pi, or let me say that pi as a radian. That pi as a radian, which is what? 180 degree. So all of these I've listed for you, they are given as what? Some examples of some types of numbers. 180 centimeter, the height of a boy. 25.5 kilometer, the distance covered by a girl. The pi as a constant, 22/7, which can be expressed as 1.141 something something something, though if it's our approximate to three decimal places, that will give us 3.142. So that is also a constant. That is also a number. So the pi as a radian, so 180 degree, that is also a number where degree represents what? The symbol or the units used in representing angles, and some other things like minutes, like minutes, seconds that we use to represent angles. So that means all of these are listed for you are actually some examples of some types of numbers. Now I'll go again. What are numbers? Numbers are arithmetical values used in representing a quantity. We measure the height of the boy. The arithmetical value now is now 180 degree. The quantity after measuring gives us a value, 25.5 kilometer. The quantity after measuring is 25.5 kilometer, the distance covered by the girl. 22/7, a constant expression for pi. Pi radian, 180 degree, also a what? A constant value of 180 degree used to represent angles. And some other examples that you can think of. So those are referred to as numbers. Now, our next talking point will be to state the types of numbers that we have. So types of numbers that we have. Now we have numerous types of numbers, but I'll just be explaining to you some very close ones that we have or that we actually need to make use of. If at all, I will still, like add some other things that we might not need at this point. Now, the first type of number is what we call the natural number. So the natural number. So the natural number is represented symbolically as a capital letter N. So a natural number is also called a counting number. That means if you don't call it natural number, you can call it a counting number. You can match the two together. Natural counting numbers. Now, what are natural numbers? We refer to our natural numbers as whole numbers, which starts from 1, progresses in that manner, whole numbers, till it's that we get to a point where it's that we can't count any longer, which is what? Infinity. So that means natural counting numbers don't have an end. So you start from 1, you move 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth, till it gets to a point where it's that you can't count any further. You are exhausted yourself to count further because it does not have an end. So such a number is referred to as a natural number, or a counting number, or you can match the two, you call it a natural counting numbers. So that is the first type of numbers. Now another type of number that we'll be dealing with is what we call the whole numbers. Now when you talk of whole numbers are represented using the symbol W. Now what are whole numbers? Whole numbers are numbers. Whole numbers are numbers that consist of natural counting number and zero. So that means whole number starts from zero and ends at infinity. Don't forget I told you, whole numbers are numbers that consist of natural counting number and zero. So that means when is that you start from zero and you move in that order, you move in that order, you move in that order till you get to a point where is that you can't count further. So that is, it has no end. That is, it stops at the point where is that we can't ascertain. So such numbers are referred to as whole numbers. So whole number starts from zero and ends at infinity. That's a non-ascertainable number. So that is the second type of number, which is referred to as whole numbers. Now, the third type of number I'll be treating with you are referred to as rational numbers. I'm going to merge the two. Rational numbers and irrational numbers. Rational numbers and irrational numbers. Now, rational numbers are represented using the symbol Q. Let me go to a new page. So we have what we call the rational numbers. So rational numbers, so represented using what we call Q as a symbolic representation, and irrational numbers. So irrational numbers are represented using what we call the symbol irrational numbers. Irrational numbers, so represented using the symbol P. Now the first one, rational numbers. What are rational numbers? Rational numbers are numbers that can be expressed as a fraction. That means you have a division sign connecting two whole numbers. In most cases, whole numbers. A division sign connecting two whole numbers. The one at the top is called the numerator, while the one at the bottom part of the division sign is called the denominator. So P and Q. Where is that our A, which is the denominator, must not be equal to 0. Because if it is that you have the denominator of a rational number to be 0, so that means that number automatically becomes infinity. That means a non-ascertainable number, which ordinarily we can refer back to as what we call a whole number or a natural number. Don't forget that we said that what whole numbers, natural counting numbers, they don't have an end. So that's that. So that means this our A, which is the denominator, must not be equal to 0 for it to be a rational number. And when you talk of rational numbers being expressed as fractions can also be expressed as a decimal. For instance, now if it's that you have a number of this nature, 5 all over 2. 5 over 2 is a fraction, and 5 over 2 can be expressed as what? As a decimal of what? Of 2.5. So that means such a number is referred to as a rational number. Let me explain deeply what we mean as a rational number. Now, the number, if it's that the number is a decimal number, the number after the decimal point the last number after the decimal point must be known. So that means it is a terminated number. It has a terminated number after the decimal point, which implies that we can ascertain the last number after the decimal point. So that means when is that you've converted the fraction to decimal, you can automatically ascertain the last number, as in the case of 2.5 now. The last number is 5. So another example of a rational number, let's say 6.125. 6.125 is a decimal, which is what? A rational number. And we know that the last number after the decimal point is what? Is 5. So that means you can convert from being a fraction to a decimal and vice versa. Vice versa in the sense that you can also convert from decimal to fraction. That means if I have this example of a rational number, I can also convert to what? I can convert it to a fraction. That will give us 6.125 over 1,000, which ordinarily can be expressed in the least fraction. But I don't want to go into that. So that means you can convert either of the two from one to another. You can convert from fraction to decimal, and likewise you can convert from decimal to fraction. So such a number is referred to as a rational number, represented using the symbol Q. Now, the other one attached to it, which is the direct opposite of a rational number, is what? An irrational number. So an irrational number now is represented using the symbol P, as I said earlier. And for an irrational number, there is no way that you can express the decimal as a fraction, which is to show that what? Such decimal numbers is a what? Is a non-terminating decimal. What do you mean by non-terminating decimal? A decimal that the number after the decimal point cannot be ascertained. The number after the decimal point cannot be ascertained. Now, for instance, the example I gave you earlier, pi as a constant, which is 22 over 7. So if you want to convert this 22 over 7, which is also, an approximate expression given to that number, that means that number will have what we call a non-terminating number after the decimal point. Can be written as 3.141 dash 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 till you get to a point where it's that you can't go further to list any numbers again after the decimal point. So that means such number is called a non-terminating number, or we call it non-terminating decimal. So that means you can't ascertain the last number after the decimal point. So that means a rational number, this is 20 over 7, is just more like, a justified way of expressing, the constant in its approximate form. Because when you look at the number itself, because 22 over 7, when pressed in a calculator, can never give us a number that we have a terminating fraction. Let me quickly bring you up to speed on this. Now, if it's that we have, for instance, now, this is a calculator. We have 22 divided by 7. Now, look at this now. It shows that what? This line drawn at the top shows that what? We have numerous numbers after it. Shows that what? Similar numbers occur after the last number, which ordinarily will bring me to our next talking point, which is what we call a form of either a rational number or an irrational number in decimal point. So we call such numbers a recurring fraction or recurring decimal. So what do we mean by a recurring decimal? Don't forget I told you, a recurring decimal is just a form of either a rational number or an irrational number. What do we refer to as a recurring decimal or a recurring fraction? A recurring fraction is that in which we have repeated numbers in that form after the decimal point. For instance, if you have 7.11111, that one is just what we have, and so on and so forth after the decimal point. So such is referred to as a recurring fraction. That means a simpler way of writing this, instead of writing just that one after it, you just write it as 7.1 and you put a dash, or you write it as what? As 7.1 and you put a dot at the top of what? At the top of that one. So that is to show that that one after the decimal point is a recurring number. So another example, this is just for one. Another example is that you have 9.212121 That means we have two recurring numbers after the decimal point, which is 2 and 1. So a simpler way of writing this is what? 9.21. You put a dash at the top of both 2 and 1 to show that they are both recurring. Or simply put, you write it as 9.21 and you put a dot at the top of each of the numbers. So that is what we call it, what, a recurring decimal. So another one, maybe if it's you have one of 3, 2.651, 651, 651, and so on and so forth. So you should know this by now, that a simpler way of writing this would just be 2.651. So you put dot, dot, dot at the top of each of the numbers, or 2.651, and you put a dash at the top of the 3 numbers to show that what? Each of those numbers, or all of those numbers in that order, are recurring. We call it repeated decimal too. If you don't call it recurring, you can call it repeated decimal. So those can be tagged as forms of either a rational number or an irrational number. Now, another type of number we'll be looking at is what we call odd and even numbers. Odd and even numbers. Odd numbers, odd numbers, and even numbers. Now, what are odd numbers? Odd numbers and even numbers. Let me combine the two first. Odd numbers and even numbers, they are both derived from natural counting numbers. Yes, they are both derived from natural counting numbers. But just that the only difference between each of the pairs is that one would divide, one of the numbers, that is the odd number, will divide 2 to give us a rational number, and the other will divide 2 to give us a whole number. For instance, now, the natural counting numbers, don't forget I told you, so 1, 2, 3, 4, 5, till you get to infinity. So now, for odd number, when you use such number, for instance, 1, to divide 2, it will give us what? It will give us a rational number. Either way, 1 over 2 or 2 over 5 is still a rational number. Now, another example, 3. If we use 3 to divide 2, it will give us what we call a what? A rational number. 3 over 2 is still the same as 1.5. So 1.5 is the same as 3 over 2, which is a rational number. So another example, 5. If we use it to divide 2, it will give us what? 2.5, which is what? A rational number. And either way, 2.5 or 5 over 2. So that means when you use such numbers, odd numbers now, to divide 2, so it will give us what we call a decimal rational number. It will give us a decimal rational numbers. So that means some examples of odd numbers. So we have 1, we have 3, we have 5. Just be moving a step ahead of the normal counting, natural counting number. 7. After 7 is what? Is 9. We move a step ahead of the number after 7. So after 9 is 11. We move a step ahead of the number after 9. So the next is 13, and so on and so forth. So such examples of numbers are referred to as odd numbers. Now the other form attributed to odd numbers is even, or let me say to natural number, is even numbers. Now when you talk of even numbers can exactly divide 2 to give us a whole number. So that means numbers that you skipped in between each of the odd numbers is an even number. After 1 we have 2. So that means 2 can exactly divide 2 to give us a whole number. Then 1 after 3, which is the next odd number after 1. So it's 4. So 4 can exactly divide 2 to give us a whole number. The next one is 6. 6 can exactly divide 2 to give us a whole number. That means numbers that can exactly divide 2 to give us a whole number are referred to as, or natural number in the real sense, are referred to as even numbers. So example, we have 2, 4, 6, 8, 10, 12, 14, and so on and so forth. So those numbers are referred to as what? Even numbers. Numbers that can exactly divide 2 to give us a whole number. Now, we've treated 4 types of number. I'm just going to do a quick recap. Natural numbers or natural counting numbers, numbers that start from 1 and end at a number that cannot be ascertained, which is infinity. So the next is what we call whole numbers. Whole numbers are numbers, natural counting numbers, and 0. So that means it starts from 0, 1, 2, and it ends at infinity. The next is what we call the rational number. So the rational numbers are numbers that can be expressed as a fraction, where is that the denominator must not be equal to 0. And such number can be converted to what? To a terminating decimal. To a terminating decimal. So the other form which is attributed to it is irrational number. So that means an irrational number is a number that does not have a terminating decimal. The numbers after the decimal point is continuous. And I gave you an instance. Pi, which is a constant, 3.141, and so on and so forth. And numbers that are just continuous like that after the what? Decimal point. And I also brought you up to speed. Okay, we can have another example, square root of 2. So square root of 2 is also an example of an irrational number. And I told you that the forms of either rational or irrational number that we have are referred to as what we call recurring or repeated decimal. Where is that the numbers after the decimal point are repeated. 6.1, 6.1111. 1111 is a repeated number after the decimal point. So you can just put a dot on the top of the one to show that it's repeated. And you can have some other examples or a dash at the top of it. So another example is what we call the odd and even numbers. Odd numbers cannot divide 2 to give us a rational number. So while even numbers exactly divide 2 to give us a natural or whole number. Now another type of number that we'll be dealing with is what we call integers. Integers. Now what are integers? Integers are numbers that consist of positive natural number, negative natural numbers, as well as 0. So that means we can refer to integers as number consisting of whole numbers, because don't forget that whole numbers are what? Positive numbers. Whole numbers are positive numbers, 0. So what you just have to do to it is what is negative numbers. That means negative natural numbers. So when you talk of positive natural numbers, you talk of positive natural numbers, you talk of numbers like our 1, 2, 3, 4, 5, and so on and so forth. Those are positive integers. Now the other one, negative integers. Now when you talk of negative integers, so negative integers are natural number that consists of negative numbers, -1, -2, -3, and so on and so forth. Now the last one, which is 0, so 0 is 0. So when is that you have a number 0? So that is an example of 0 as a number, or you say nil, nothing. The number does not have an effect when it is being added or subtracted from something. So that is called what? 0. Or a number that nullifies something when you use it to divide another number, unless it is what? Unless it is a denominator, or it nullifies the number when you use it to multiply another number. So 0. So that means we have negative integers, which are negative natural numbers. We have what we call positive integers, which are positive natural numbers, and we have zeros. So all of these numbers, which are integers, they can be represented, though, on a number line, but I would say that a number line can also be tagged as a line that consists of both rational and irrational number, because a number line doesn't just contain whole numbers. A number line can consist of what we call decimal numbers. So that means we have 0 at the middle. So we have positive numbers to the right of 0, and we have negative numbers to the left of 0. So those negative numbers, positive numbers, they might not necessarily be whole numbers. So we can have decimal points in between, between 1 and 2, we have 1.5. Between 0 and 1, we have 0.5. Between 1 and 0, we have minus 0.5. Between minus 2 and minus 1, we have minus 1.5. So we can say that what? A number line. It's a number line. I'm going to shorten the word number as this. So a number line can consist of what we call either whole numbers and decimal numbers. And those decimal numbers. And those whole numbers are referred to as, integers, positive whole numbers, negative whole numbers, and 0. So you also talk of what we call decimal numbers. Now, decimal numbers in the form of what? Rational number to be specific. Rational numbers to be specific. So that is another example of numbers. Integers. And integers are represented using the symbol Z. So we use the symbol Z to represent integers. So another type of number which cut across all of the numbers that we've mentioned so far, we refer to them as real numbers. So we refer to them as real numbers. And real numbers are represented using the symbol R. So it cuts across natural counting number, it cuts across whole numbers, it cuts across rational and irrational numbers, it cuts across odd and even number, it cuts across integers. It cut across integers. I guess it also cuts across complex numbers, which I'll be treating with you after this. So that means any form of number that ever exists is called a real number. A number, an ascertainable number, is referred to as what we call a real number. A number that you can ascertain. That is referred to as what we call a real number. So now that is what the sixth type of number that we have, a real number represented using R. Any form of number at all is referred to as a real number. Now I'm not going to bring you up to speed on some other forms of numbers that we have. So which I've mentioned one earlier. So you talk of what we call the complex number. So the complex number. Now when you talk of the complex numbers consist of the expression I. That is an imaginary expression. So where is that what? Our I is equal to square root of minus 1. So square root of minus 1. So such a number is referred to as a complex number. And we use it when is that we have, a root that has a negative expression. For instance, if it's that you have a complex root or an imaginary root of minus 36. So minus 36. There's no way you can press a calculator and it will give you the square root of minus 36, or the square root of a negative number, unless is that calculator is programmed to be in complex numbers. So that means if you want to write the square root of 36 now, that can be written as square root of minus 1 times 36. So you let the 1 have the minus sign. So if you want to separate it using sort, you have square root of minus 1 times square root of, let me write this first, times square root of 36. So that means you separated them. So automatically you can obtain the square root of what? Of 36. So square root of 36. So we know our root minus 1 to be equal to I times our square root of 36 is 6. So that will give us what? 6I. So that means an expression that has what? That is of a negative root is referred to as a complex number. So that means root minus 36 can be written as what? 6I. So those are called what? Complex number. And they have all called what? A complex root. That is a root that has what? A negative number. A negative number. So that is that on complex numbers. Now, another form of numbers, which I'll be emphasizing in our next video, and I'll be channeling to dealing with some things in math as we progress, is what we call prime numbers. Prime numbers. We'll be applying prime numbers in obtaining what we call the factors and multiples. We'll be applying prime numbers to obtain the HCF and LCM of numbers. I'll be applying prime numbers, and different things. So we gradually we build on it like that till is that we move on to what we call factorization, and the types of factorization that we have: factorization by HCF, factorization by common bracket, and factorization by grouping, which will be our next talking point in our next class. So that means in our next class, I'll be dealing with what we call prime numbers. I'll be dealing with what we call factors and multiples. I'll be dealing with what we call HCF and LCM. And after that, we'll move on to factorization of number. Don't forget, at the end of this video, I want you to like, share, and subscribe so that we can have more of these videos. Thank you, and God bless.